So you're a developer and you need to pull text out of an image. You've got options, but which OCR tool do you actually bet on? Well, let's dive into the ultimate showdown and find a clear winner for your next project.
And that right there is the big question, isn't it? On one side, you have these popular open-source workhorses, and on the other, a brand new AI powerhouse. Stick around, because by the end of this, you are going to have a clear, practical answer based on some real-world, in-the-trenches testing.
All right, so let's kick things off with the classic matchup. You know, the one we're all familiar with. In one corner, we've got the long-standing veteran, Tesseract, and in the other, the powerful deep learning challenger, EasyOCR. Now, both of these are free, they're both super popular, but, and this is key, they are built for very, very different kinds of fights. Okay, here's the absolute core difference. I want you to think of Tesseract as a sprinter. It is incredibly fast, super efficient, but only on a clean, straight track. EasyOCR, on the other hand, that's your all-terrain vehicle. It's built for mud, for hills, for messy, unpredictable conditions. It's not going to win a drag race, but it'll get you where you need to go, no matter the terrain.
So when do you actually use the sprinter? Well, Tesseract absolutely shines when the text is predictable and clean. We're talking about things like crisp scanned PDFs, standard printed invoices, or maybe screenshots with really simple, clear fonts. You know, for standard English on a nice clean background, it's a fantastic, super lightweight choice.
But what happens when that road gets bumpy? That's where EasyOCR, our all-terrain vehicle, just takes over. It is designed for the chaos of the real world. You know, text that's on a curve, noisy backgrounds, and especially languages with complex accent marks like Vietnamese. Honestly, it's the tool you'd pick for reading text from a comic book or a meme. Look, theory only gets you so far, right? So let's see what actually happens when these tools face a real test. We're going to move them out of the clean lab and into a messy, real-world production scenario and just see which one cracks under the pressure.
And our stress test is, well, it's particularly nasty. We're going to try to extract text from a Vietnamese comic book. This is basically the ultimate challenge. You've got stylized fonts, you've got colored backgrounds, and you have a language that is filled with diacritics, you know, all those little accent marks above and below letters that can completely change a word's meaning.
And, hoo boy, the results are telling. The original Vietnamese sentence is right there at the top. And below it, that's Tesseract's output. It's complete and utter gibberish. This isn't just a small error. This is a total, catastrophic failure. This is our sprinter trying to run through a swamp. It's just not going to happen.
So what happened? Why did it fail so spectacularly? Well, it all comes down to something called segmentation optimization. Tesseract's core engine was fundamentally designed years ago for clean, structured, English-like text. It just wasn't built to handle this crazy combination of heavy accent marks, curved fonts, and colored backgrounds all at once.
Now, EasyOCR, it handled the Vietnamese text much, much better. It actually worked, but it introduced a huge plot twist. That accuracy came at a serious price. In the production test, it was so resource-intensive that it ended up eating nearly one full CPU core just constantly. And that gets really expensive really fast when you're paying for server time by the hour.
And this is exactly where our story takes a sharp turn. This struggle, this trade-off between local speed and local accuracy, it created a huge opening for a third contender to answer the ring, OpenAI. And this isn't just another OCR engine. It's a fundamentally different way of even thinking about the problem.
I mean, forget about installing libraries, managing servers, and all that headache. OpenAI works more like a cloud consultant. You just upload an image, you make a dead simple API call, and boom, you get the text back. It handles all the heavy lifting. The models, the scaling, the infrastructure, all of it happens on their end, not yours.
So, let's get to the final showdown and see how this all really stacks up. We're going to compare all three of these contenders across the metrics that truly matter to any developer. How much your infrastructure costs, how fast you get results, and of course, how accurate the output actually is.
You know, this table right here tells such a powerful story. Just look at that CPU usage row. OpenAI uses exactly none of your CPU. And then check out infrascaling. With Tesseract and EasyOCR, you have to manually add more servers as your app gets more popular. With OpenAI, it's completely automatic. You literally shift from paying for servers to just paying per image.
Okay, so what about speed? Now, on a per-image basis, yeah, the local tools are faster. Tesseract is incredibly quick, around 300 milliseconds. OpenAI is the slowest here, at about 2 seconds per image. But, and this is a huge but, this doesn't account for all the time you'd spend managing infrastructure or batching jobs, which is where those local tools can really start to bog down.
And here it is, the real jaw-dropper, the cost. We're talking about roughly 1/10 of a single cent per image. The real-world test from the source article, which ran for an entire month, cost a grand total of 20 cents. That is so much cheaper than paying for a dedicated server running at high CPU 24/7.
So after all that, what is the verdict? We've got our data, we've seen the real-world tests. Let's distill all of this down into a clear, actionable recommendation you can actually use for your next project.
So here's the most important takeaway. There is no single winner. It completely depends on the job you're trying to do. You're going to use Tesseract, the Sprinter, for those clean, simple English documents. You'll use EasyOCR, the all-terrain vehicle, for complex, stylized text. And you choose OpenAI, the cloud consultant, when you want maximum accuracy with zero infrastructure headaches.
But for those of you who want the absolute best of all worlds, there's this really clever expert-level hybrid approach. You start with a fast, cheap, local tool like Tesseract. Then you check its confidence score. If it's low, only then do you send that one tricky image over to OpenAI for the high accuracy, slightly slower analysis. You get speed and low cost for all the easy stuff, and you get pinpoint accuracy for the hard stuff. It's brilliant.
And all of this leaves us with one final, kind of provocative question. As these big AI models get cheaper and more powerful, are we actually seeing the end of self-hosted OCR infrastructure? For a lot of developers, the answer is increasingly yes. The future of reading text from images might just be a simple API call away.